Hello everyone, I'm Phil Wickens, and there's been a request for a Crumble controlled flood barrier model for people to make in school. So I've been thinking about this, what would be a solution for that? I think we need to talk to an expert. Here is Professor Ivan Haigh.
Thanks, Mr. Wickens. My name is Ivan Haigh. I'm a professor at the University of Southampton and I specialise on flooding. Now, when it comes to protecting cities and towns and houses from flooding, you can't have doors, you can't have barriers that move this way because of water pressure. It's just too hard. So what you tend to have is a door above the ocean that drops down and sort of protects it, or that sits on the bottom and comes up. And that's what happens with the Thames barrier and also the barrier in Hull and other barriers around the world like in the Netherlands. Thanks, Mr. Wickens. Back to you.
Well, thank you, Professor Haigh. That was awesome. So we know that we can't have a door underwater because there's too much pressure from the water to try and open the door against it. So instead, we need something, like Ivan said, to go up and down inside the water. If the water is flowing through, if we push it down, it will stop it. If we lift it up, the water will come through again. So we need to figure out how we could do that. Let's have a look. Now, I did think first about using a servo, but the servo only kind of moves in a circular direction 180 degrees. So that would be almost like the door opening and closing like that. If you were going to do some kind of vertical thing, then again, whatever was attached to the servo would move in a circular motion like that. So you could have some kind of vertical barrier like this, but it would be quite complicated to make because it would have to be sort of in a circular motion. So let's leave our servo for now, and I've come up with this solution, which is a dual motor setup. Forgive the crudeness of my model, it's not to scale and I didn't have time to paint it, but imagine that this is our waterway. Okay, so the water comes in that side and out this side. Other margarine is available. And what I've done is I've set up two motors here. I've poked them through at exactly the right distance apart so that the wheels just about touch. And I've taped the motors down so that they don't kind of rotate around. And what I've done, I've slid in this nice thin barrier that is pretending to be the barrier for the water, and I've made a couple of little guides here for the barrier to be able to slide up and down. And what I've done is I'm going to program the Crumble to turn the wheels in opposite directions for a certain amount of time to raise up my barrier, and then again wait for a bit and then go down again. So here is my code. Let me see if I can get my code up on the screen. La la la, let's just hide everything else. Right, okay, so this is my code. So when the program starts, and I've got a big forever loop because I'm gonna do it as if it's going on and on and on, timed. So as you can see, I've got motor 1 and motor 2. One's going forward, one's going reverse. 30% is fine because I don't want it to be flinging that barrier up and down. So nice and slow. Then I make the motors stop for 5 seconds and then I reverse them. So the one that was going forwards is now going reverse, and the one that was going reverse is now going forwards to make the barrier go back down again, and then there'll be a 5-second wait. So let's just see what that looks like. If I sort of hold my camera here and turn on. Right, I'm on and I'm going to press play. Here we go. So there we go. So it lifts my barrier up, waits 5 seconds, and then it should close the barrier again. Let's have a look at that from a different angle. Here we go. There we go. Can you see the barrier is sandwiched between the two wheels? So that as the wheels turn, it kind of moves the barrier up and down. Now in real life, you wouldn't use wheels with tyres on. You'd probably use a gear system where these would be cogs, and this would have like a rack of straight line cog on it so that it would have more of a grip. But can you see, if I'm water rushing through here, I'm not going anywhere, not going anywhere. Oh, now I can go, now I can go, now I can go. And then it stops again when it goes down. Brilliant. So we have a working model of a barrier system. But this is on a timed system. So what if we wanted to control it ourselves with a push button? Well, let's have a look at that. Just before we do that though, I want to show you something. I've added a light, and the light is green. Oops. And then when the sluice gate or the flood barrier is working, it goes red, just to warn people that it's working. There we go. So that's what that code looks like. And you could set the light to do anything. You could set it to flash before it moves, or you could say it's going to be one colour when the barrier is up and another colour when the barrier is down. So you're just adding a little sparkle bit at the start of each section when the motors are being controlled. So there we go, nice little LED. But let's get a switch involved and see if we can control this ourselves. Okay, now we have this manually controlled with a switch. Let me just show you my wiring diagram. So my two motors obviously go to the bottom of the Crumble, so motor 1 and 2. And then I've got my LED coming off this top bit here. So plus and minus and D. And D goes into the LED, obviously, for D, where the D arrow is. My switch comes from one of the positive terminals on the battery, goes into one side of the switch, and the other side of the switch goes into A. Because if you think about it, what I want to do is say, when I press the switch, activate the motors. Well, it's another way of saying when terminal A detects a current, because the current is coming along here to the switch, and when I press the switch it connects that side to this side, which means the current will go all the way through green to A. So I want A to be saying when I get a current, and in Crumble speak it's when A is high. It's a high current, not a low current. So when A is high, I press it and it should do something. So this is what my code looks like. So I've still got my big forever loop, because I want it to be going around and around again. And it says wait until A is high. So it's waiting for me to push the button. It's going to make the light go red. It's going to make the motors move. And then it's going to wait a second and tell me that it's finished. Oh, so the motors are going to move for that long, 1.5 seconds, which is enough to get the barrier up. It's then going to go green to tell me that the barrier is up, and it's then going to wait again with the motor stopped until I press the button again. And then the light is going to go red, it's going to put the barrier back down, and when the barrier is down, it's going to go blue to show me that the barrier is down. And then because it's looped, it's going to wait for me to push the button again. So let's see this in action. Are you ready? So my light is blue, telling me that the barrier is down. I'm going to press my button. You should see a red light and the barrier go up. There we go, the barrier is up, excellent. And we have a green light telling us the barrier is up. If I press it again, the light should go red and the barrier should come down. Let's see if I can do it from this angle. You ready? 3, 2, 1. Brilliant, there we go. So we've got a working, manually controlled flood barrier. Isn't that cool? Awesome. Now what you could do, you could hook this up instead of a switch. You could use your light sensor so that when it goes dark, the barrier comes up or goes down, and then when it gets light again, it activates it the other way. So that could be another way that you could do it if you wanted a nighttime only barrier. But yeah, I think this worked pretty well. Awesome. Have fun with your flood barriers.